Hi everybody and welcome to another 5-minute masterclass. Today's topic is sequences and finding the nth term. So I've got some examples here to support you today. Remember, when we're trying to find the nth term, what we're trying to do is to find the rule for the sequence so that I can find any term within that sequence, whether it's the next one or whether it's the 10th or the 100th or even the 1000th. It's useful for then working out whether particular numbers are within a sequence or how many terms are greater than or less than a number. So it's a really useful thing to be able to do. So in this example, what I'm trying to do is find the nth term for this increasing sequence. The first thing we need to do is to consider, well, what type of sequence is this? Because they're all versions of a times table. We're interested in which one that is. So I'm looking at the difference between each term in the sequence. So I'm thinking, how do I get from 5 to 9? Well, I add on 4. If I look at this one here, to get from 9 to 13, well, I add on 4. 13 to 17, I add on 4. And 17 to 21 is plus 4. Now, the only sequence in the world that goes up in 4s is the 4 times table. And so that's 4 times a number. But we can simplify that, as we always do in algebra, to 4n. Okay, now obviously this isn't the 4 times table, because we know the 4 times table is 4, 8, 12, 16, 20. And we don't want that. We want 5, 9, 13, 17, 21. So we're asking ourselves the question, how has this times table shifted? How have we gone from 4, 8, 12, 16 to 5, 9, 13, 17? Well, to get from 4 to 5, I need to add 1. To get from 8 to 9, I need to add 1. From 12 to 13, add 1. So you can see repeatedly, I'm adding 1 each time. So our answer, our nth term, is the 4 times table, but moved up the number line 1 space. So for each time you're trying to find the nth term, you're asking yourself 2 questions. What times table is it in, and how has it shifted? I'll show you again here for this example too. This time, however, notice the sequence is decreasing, it's going down. So the rules don't change, we still do the same thing. We're going, how do I get from one term to another? So to get from 3 to 1 is -2. To get from 1 to -1, still -2. Still -2, and from -3 to -5 is -2. So the only sequence in the world that goes down in 2s is going to be my -2 times table. So -2 times a number, which we know simplifies to -2n. But we need to consider what that times table is. So the 2 times table is 2, 4, 6, 8, 10. So the -2 times table is going to be -2, -4, -6, -8, -10. And so we're asking ourselves, how has this times table shifted? I don't want to be at -2, I want to move to 3. So considering that number line, if I start at -2, to get back up to 3, I need to move up 5 places. And I can check that for all of them. If I start at -4, to get to 1, I need to move up 5 places. To get from -6 to -1, I need to move up 5 places. Notice how it's the same for each one of these. That's how it should be. So completing our nth term is -2n plus 5. Now you could rewrite that if you wanted it to be the other way around, which is to say that I start at 5 and then we go down in 2s. But either of these is equivalent and it will be fine no matter what you say. Okay, on to equation example number 3 then. This time I've got a geometric sequence. So by that I just mean that we have drawings. So it might be things like here with petals, it might be matchsticks, it could be counters. There's lots of different ways for people to illustrate a pattern. But here we've got the number of petals on a sunflower is represented as a linear sequence, and we want to write an expression for that. So write an expression in terms of n means we want to find that nth term. That's what it's asking for. And so because we're talking about the number of petals, the first thing I'm going to do is count them. So I've got 1, 2, 3, 4, 5 petals for pattern number 1. And I've got 1, 2, 3, 4, 5, 6, 7 for pattern number 2. And 1, 2, 3, 4, 5, 6, 7, 8, 9 for pattern number 3. Now because it's linear, that means it's going up by the same number each time. And we can see that if I write it out here, 5, 7, 9, then I can see quite clearly that we're going up in twos. And as we said before, for example, 1 and 2, the only sequence that goes up in twos is the 2 times table. And so I can write that into my answer box straight away. It's 2n. But the 2 times table is 2, 4, 6, and I don't want that. I want 5, 7, 9. So we're saying, well, how have I shifted this number line? How have I moved it from 2, 4, 6 on this sequence up to 5, 7, 9? Well, each time I'm adding on 3. 2 plus 3 is 5, 4 plus 3 is 7, 6 plus 3 is 9. So that means that my nth term is 2n plus 3. Okay, sometimes it could be less, so it could be negative. As you've seen over here in example 2, our n can be negative. It's just a case of asking those 2 questions. What times table is it in? How is it shifted? Okay, so it's over to you. Pause the video, try these questions. When you're ready, press play. Here are the solutions. I hope you've been successful. And if you need any further practice, take a look at Sparks, Corbett or Maths Genie for further videos and questions. Thank you for your time today, and I'll see you again for another 5-minute masterclass.